from rod of weight W, AB, length 2L, so that's L there and that's L there, and resting against a smooth vertical plane, so therefore it's going to have a normal contact force there, which I'll call R. I'll call it RA. And and B resting on a rough section of a hull. So this is a rough section of B, so that's going to be RB. And it's rough, so it's going to have friction, so it's going to want to slide that way, so it's going to have to oppose motion, so there's going to be friction there. This length, another uniform rod of length root 3L, so that means the whole of that length is root 3L, the whole way there. And D rests on a smooth section of the plane, so that will have a normal contact of things. That'll be RD. And I think that's pretty much. There's obviously going to be a force here because it's coupled here, but there's an internal force, and I don't know where it's going to go. Pretty obviously, it's going to have to go straight down though, because it can have no left or right movement. Otherwise, the rod CD would be accelerating left or right. So I think that's the thing done. Although say there's internal forces here as well, I'll make sure I can see the forces. So I'll put those forces in green so I can just see them and know where we are. Right. Show that the force exerted by the horizontal plane on CD is a half W. So I've got to show that RD is a half W. So obviously it's going to be moments because I don't know what this force is here. So I'm going to have to take moments about C for CD. And I'm going to have anti-clockwise equals clockwise. So the anti-clockwise will be RD times by the distance. And the distance we've got is the perpendicular distance, so that will go all the way to there. That's the distance we're after. So that will be root 3L, and that'll be cos 30. Root 3L cos 30, and that's just got to equal the clockwise moments, so that's the W force here, so it's going to equal W, and that will times by root, that's going to be half of that, so root 3L over 2 times by cos 30. Obviously the cos 30s cancel out, and we get that's the L's cancel out 2, and times, or divide both sides by root 3, and that's going to give us that RD equals W over 2. So it's done the first bit, and now find the normal component of the force exerted by the horizontal on AB. So I've got to find. So we've got this one here being W over 2. We've got W coming down here, so there must be a force upwards on CD of W over 2, and therefore there'll be an equal and opposite force going down there of W over 2. And then we can just work out, we can resolve upwards for AB, and we get the upwards equals the downwards. And so we've got upwards, we've got just the RB. So we got RB equals what's going upwards? Well, it'll be the one which goes downwards. W plus W over 2. So RB equals 3 over 2 W. Part 2. Find the magnitude and direction of the force exerted by CD on AB. I think I've already done that, because we know that it's got W over 2 here, W going down, so it's got to be W over 2 up here. So if I resolve vertically for CD, then I get W over 2 plus something equals the force downwards W, so that bit, the the unknown is going to be W over 2. So that goes up W over 2, and therefore there must be an equal and opposite force straight downward of W over 2. So therefore W over 2 down on AB at C. And I think I've already done that bit. Given that AB is in limiting equilibrium, find the coefficient of friction between A. So I need to find out this F. I know what this RB is. RB equals 3 over 2W. I've already got that bit there. So I need to find out what the F is. So therefore I'm going to need to take moments about A for AB. And that means I'm going to have the anticlockwise equals clockwise. So what I've got anticlockwise, I've got this RB. So that's 3 over 2W times by the distance. The distance is 2L, and it'll be cos 60. 2L cos 60. And there's no other force going anti-clockwise, and then forces going clockwise has got to equal this force here, which is W plus W over 2. So that's 3W over 2 times by that'll be, well, that's L, so it'll be L cos 60. So that's just an L cos 60. That was a 2L cos 60 because it's the whole length. This bit is acting in the middle here. I just needed to find that horizontal distance there. So it's L cos 60 plus, I've obviously got this F. So that's F times by this bit here, which will be 2L sine 60. F times 2L sine 60. And that will give me, well, the L's all cancel out. So L goes, L goes, L goes. And cos 60 is a half, so half times 2, so that goes 3 over 2W equals cos 60. Again, that's a half, so that'll be 3/4. So 3/4 W plus, and I'm going to do it as a decimal now, that'll be 1.732 F. And so then I can work out what that is. F equals 1.5, so that'd be 3/4 or 0.75 W over 1.732, and so that means that F equals 0.4330 W. So I know what F is, I know what that is, and so I've got limiting friction equals mu R, and so I get mu equals, that will be F over R. Friction is 0.4330 W divided by R, which is 1.5 W, and that gives me that mu equals 0.288675. You could have used sine 60 being root 3 over 2 and stuff, but decimals are fine, unless it says exact values. And that's question 6 done.